We talked a little bit about series circuits yesterday, and we said that the resistance is the total of all of the resistors that are in that one pathway, right? So electrons come out, and when they go through, there is only one pathway for them to go, and so to add up the resistance of the whole entire circuit, you just add up the resistors that are in series. And we said that the current, because there's only one pathway, remember current doesn't get used up, it's the flow of electrons, so you don't get electrons that disappear. So the electrons are the same everywhere. That's like water going through a pipe. All the water has to go through every single place. So the current is the same. And then voltage, we said that Kirchhoff's loop rule is the sum of all those voltages have to add up to 0, which basically means if we add 30 volts here, then we have to lose 30 volts in every other place that has any sort of resistance. So if we start at C, we would add 30, and then when we went through, we might lose 20 volts, lose 10 volts, and then get back to C, so there would be a net change of 0 volts, right? So the voltage of the battery are 30 added up to all of the voltage that was lost in the other resistors. So if we were going to actually make that calculation, we are going to use Ohm's law over and over and over again, which is I equals V over R, or sometimes you'll rewrite it as V equals IR, depending on what you're looking for. So it says to find the voltage across a certain resistor in a series circuit, use the following law. Well, we need to figure out how much current comes out of the battery first. So the first step, you always find the total resistance. Now, you need to write out your formula. Actually, I'm not going to make you write out your formula, but it looks like this on the formula sheet. The sum of the resistors in series equals, and then it just has a dot, 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 because you just add them together. So I am going to show that the total resistance is 2 plus 1 and 3 ohms. Yes, you have to show that work. Step 2, I'm going to figure out the current. These are always the first, almost always the first two steps that you do. So the current that comes out of the battery is equal to the total voltage, or the voltage of your battery, 30, over the total resistance of your circuit, which we said was 3. Therefore, 10 amps is going to come out of the battery. And then if we want to find the voltage drop in any one point, we're going to use this equation, but we're going to use it specifically for that point in the circuit. So if we want to figure out the voltage drop here, then we're going to take that bulb 1, right? If we want the voltage of bulb 1, we're going to take the current that goes through bulb 1. Well, because it's series, all the current goes through it. And we're going to take the resistance just of bulb 1, because we want to find the voltage of bulb 1. And therefore, there's a difference of 10 volts across that resistor. If we wanted to find the voltage of bulb 2, we would do the same thing. The current that goes through bulb 2 is 10 amps, and the resistance of bulb 2 is 2, and that tells us that we lose 20 volts. And that follows Kirchhoff's loop rule, right? We gained 30, we lost 20, we lost 10, and we're back to 0. We're going to skip our parallel circuits right now. So here's another example, right? Like I said, the first step we're going to do is always find the total resistance. So that's our RT. So if we have two 2 ohm light bulbs in series, it's just 2 plus 2 is 4 ohms. The current that comes out of the battery is voltage over resistance. The voltage of the battery is 24. The resistance of our whole entire circuit we said was 4. And so 24 divided by 4 is 6 amps. So that means 6 amps goes through every single point in the circuit. So 6 amps goes through I2. 6 amps goes through bulb 1. 6 amps goes from A to B. Right? 6 amps goes from B to C. Every single place in the circuit is 6 amps. So there's no work that you have to do on these series circuits after you find the initial current. Okay, the voltage across the 2 ohm. Remember, I said that we are going to use the current that goes through the 2 ohm and the resistance of the 2 ohm to find that value. So the current, because it's in series, is 6 amps. The resistance of just that one light bulb is 2, therefore it loses 12 volts of electric pressure when it goes through that bulb. Well, the voltage of bulb 2 is the exact same thing, right? Because 6 amps goes through that 2 ohm bulb and it loses the other 12 volts. That follows Kirchhoff's loop rule. We would gain 24, we would lose 12, we would lose another 12, and then we get back and it's 0 again. So our numbers make sense. Let's see, voltage from A to B. Well, if I want the voltage from A to B, I got to do the current from A to B and the total resistance from A to B. Well, it's a series circuit. 6 amps goes through the pathway. Now, from A to B, there are 2 light bulbs that are in series together that had a total of 4 ohms of resistance. So, I put the total resistance in that pathway of 4, and there's a difference there of 24 volts. The voltage from B to C. This is the one that messes people up. The current from B to C and the resistance from B to C. Well, 6 amps goes from B to C in current, but how much resistance is there from B to C? Assuming we have these crazy wires with no resistance, there's no resistance. Therefore, there's no change in pressure. That's not saying that the electric potential is 0. It's saying that there's no change in electric potential from B to C. Power of the battery, right? That is the power supplied. And yesterday I said that that is IV. So the current coming out of the battery is 6. The voltage of the battery is 24. And 6 times 24, right, is 144 watts. So the battery supplies 144 watts. When you talk about the bulb, well, it's using power, so I'm going to use I squared R for that one. The current that goes through the bulb, we said, was 6 amps, so 6 squared. The resistance of that bulb is 2 ohms, so 6 squared times 2 gets us 72 watts. Right, that makes sense. The battery supplies 144 watts. Now all that power has to be used, so 72 watts is used here, another 72 watts is used here, and our 2 light bulbs used all the power that was supplied to the circuit. So series circuits are pretty easy. I know I went fast. Go back and look at it again if you need to. But just remember, when you're doing equations, plug in numbers that are specific to the one point that you're concerned about, and always start with finding your total resistance and the total current coming out of a light bulb. There's one more in here. What I'd really like you to do is try to pause the video and try this one yourself. See if you can find these values. And then I will show you, and then hit play again, and then you'll see the answers. Right, and here are those answers. So at this point, you should be able to do the homework. The homework is only on series circuits, so you should be good. Okay, that's it.